Assalamualaikum warahmatullahi wabarakatuh. Now we are going to talk about the introduction. Gas chromatography is a technique for separating components depending on volatile and based on different of boiling point. In gas chromatography, the components of a vaporized sample are separated as a result of being partitioned between a mobile gaseous phase, a liquid or a sample stationary phase held in a column.
The researcher developed a method for analyzing vanillin and ethylene in milk powder using auto headspace solid phase microextraction and gas chromatography mass spectrometry. Due to its vanilla scent and strong milky flavor, vanillin and ethylene vanillin are commonly applied as food flavor enhancer. Vanillin 3-methoxyl-4-hydroxybenzaldehyde and vanillin 3-ectoxyl-4-hydroxybenzaldehyde are flavoring additives used in the food industry. The maximum usage of vanillin, ethylene vanillin and vanilla extract in a formula for infants over 6 months old and children is 5 mg, 1000 ml, volume ready to use, instant food and the prescribed amount according to processing demand respectively. The maximum amount of vanillin allowed in newborn supplementary cereal food is 7 mg, 10 gram instant milk. Gas chromatography, spectrophotometry, high-performer liquid chromatography, voltammetry, capillary electrophoresis, liquid chromatography coupled with mass spectrometry and gas chromatography coupled with mass spectrometry are among the methods for detecting vanillin and ethylene vanillin in milk powder extract that have been published in the literature so far. This researcher created a promising method for sampling complicated mixtures that are allowed for direct extraction and concentration of analyte from the original matrix without the need for time-consuming intermediate process. The analytical method for determination of vanillin and ethyl vanillin content in milk powder developed in this study has some practical value and application potential.
Assalamualaikum warahmatullahi wabarakatuh. My name is Azman. I'm going to talk about methodology. Reagent and materials. First, we have sodium chloride that was baked for 2 hours at 400 degrees Celsius, then cooled to room temperature in a desiccator. Then acetonitrile. Third, deionized water, standard vanillin and ethyl vanillin, SPME devices which include 100, 30 and 7 micrometer polydimethyl silane coated fiber, 65 micrometer PDMS, divinyl benzene coated fiber, 85 micrometer polyacrylate coated fiber, 85 micrometer carbon molecular sieve, and lastly 30 micrometer divinyl benzene. Sample preparation. In 20 ml headspace bottle, milk powder 1.0 plus minus 0.001 gram and 2 gram sodium chloride were added with 5 ml deionized water, and the solution was mixed using an MS3 basic turbine mixer for 3 minutes. Standard preparation. 0.050 gram of standard substance was dissolved in acetonitrile to form a final 100 ml solution for the vanillin and ethyl vanillin standard stock solution. Then the 10 ml standard stock solution was diluted with acetonitrile to make 100 ml of vanillin and ethyl vanillin intermediate solution. Then the standard intermediate mixture solutions were progressively diluted with a blank milk powder matrix to generate a series of matrix mixture standard working solutions. On the day of the analysis, the solution should be freshly prepared. Lastly, after the measurement under instrument working conditions, standard curve with peak area versus analyte concentration were plotted. graph shows the results of the experiment. Extraction fiber type. The 65 micrometer PDMS DVB extraction fiber was the best under the temperature of 70 degrees Celsius with oscillator rotation rate of 500 rpm and incubation time for 10 minutes. This is because during absorption, a hysteresis effect was generated when the component content was high and was significantly eliminated when it was low. Incubation time. 40 minutes was chosen as the optimal incubation time because when greater than 40 minutes, the increase of the peak area was not apparent as the increase of incubation time, which indicated the vapor-liquid equilibrium was achieved at 40 minutes. Oscillator rotation rate. 500 rpm was the optimum oscillation rotation rate because when above 500 rpm, the peak are no longer increased. The faster the rotation rate, the larger the peak. This is because the increase of rotation rate not only accelerate the evaporation of volatile components into a gas phase, but to also enhance the airflow in the airspace, which increase extraction efficiency. Extraction temperature. The results show that vanillin peak regions achieve their greatest value at 80 degrees Celsius. This is because of the partition coefficient of extraction fiber and the extraction efficiency could be reduced at higher temperature, although high temperature helped to extract the analytes from the matrix. Extraction time. Within 10 to 30 minutes, the peak regions of the analytes increased as time passed. The peak area became stable as the extraction time passed 40 minutes, indicating that vapor-liquid equilibrium had been reached. Desorption temperature. The best desorption temperature was determined as 260 degrees Celsius because the response peak areas of vanillin and obtained maximum values at this temperature. Desorption time. After being absorbed on extraction fiber, the analytes must be entirely desorbed over a period of time. At 5 minutes, the analytes peak regions no longer change and would not respond if desorbed again. Because high temperature could impair the extraction fiber's service life, standard solution of vanillin of 0.05, 0.25, 0.5, 1 and 2 were used to construct calibration plots. Based on the table, for infant milk powder, the maximum concentration of vanillin is 1.27, while for on formula is 80.42. For minimum, both infant milk and on formula have lower than 0.1 concentration.
For conclusion, in this study, an auto technique for determining the amount of vanillin and ethyl vanillin in milk powder was developed. Simple pre-treatment considerably reduced the interference of sophisticated matrix in milk powder in this producer. The sample spiking recovery range from 90 to 100% with an RSD of 1.9 to 5.1%. The LODs were 0.1 and 0.05 mg kg respectively, within the range of 0.1 to 2 mg kg and 0.05 to 2 mg kg. Vanillin and ethylene show good linearity with calibration coefficient of 0.9992 and 0.9991 respectively.
High analytical efficiency, a simple operational process, a wide linear range, a low detection limit, strong selectivity, minimal interference, and a good survey were all advantages of this approach.
As a result, the validated method is suitable for determining the concentration of vanillin and ethylene vanillin in milk powder quickly.